So when we talk about angle bisectors, and what we've been doing is the angle bisector theorem, if a point is on the bisector of an angle, so like say point E, and then it is equidistant from the sides of the angle. So it is equidistant from the sides of the angle would have been ABC. And then the converse to that is if a point in the interior of an angle, so we have angle ABC, so E is the interior point. If it is equidistant from the sides of the angle, then it is on the angle bisector. So what that tells us here is when we're doing this, even if I throw all that bisector stuff out, and let's just talk about congruent triangles, I have triangle ABE, and it is going to be congruent to triangle CBE because we have a 90-degree angle, so we have a hypotenuse leg. So I could say that these two triangles are congruent for a hypotenuse leg, and of course all my corresponding parts would be congruent, and therefore this angle is also 43 degrees. So it says the measure of angle ABE is 43 degrees. So using some of those principles of the stuff that we've come up with, carrying that down here and here, if this point is equidistant, then it's on the bisector. Or should I say, if I can look at this, I can say, oh, this angle is congruent to this angle, therefore this is on the bisector. Then it is equidistant, so I could just make, in this case, MK is going to equal KT, and do the substitution in there and say, okay, 2x plus 1 is equal to 3x minus 8. Simplify, find out that x is going to equal some number. And if I had to guess, x is going to equal 9. Doing your inverse operations, and then come back in here and plug that value in. And it would be 3 times 9 minus 8. So there you go. We have 27 minus 8 is going to be 19. So as I continue on just looking at some of these examples, let's see, I know here looking at this that if this is a 90-degree angle, this is a 90-degree angle, this is 2, this is 2, looks an awful lot like a square. But either way, I could turn around and say that if this is G is equidistant from the sides of the angle, MAD, then this segment is equal to this segment, and this angle is equal to this angle. So you just set that up as, 12x plus 23 is equal to 10x plus 27, and you would simplify. So, and then you would eventually find GAM, which is going to be this measurement right here. So we would substitute x in there, so we would have 10 times some value of x plus 27 is going to be the measurement of angle GAM. So that's how we work through some of these problems. And then when we talk about the end center is where all of my bisectors, angle bisectors meet. And looking here at this example, let's see here, all of my bisectors meet at the end center of A. So that tells me that this angle is equal to this angle, this angle is equal to this angle, this angle is equal to this angle. So with that, I should know quickly that that's 40 degrees. I should know that this angle equals this angle, so I could find out what the heck x is. If I understand that, like say if I do this, let's see, I'm going to solve for x. So 3x plus 2 is equal to 4x minus 9. I'm going to subtract 3x from both sides, combining like terms, and I have 2 is equal to x minus 9. Add 9 to both sides, and x is equal to 11. Well, if I plug 11 back in here, I have 4 times 11 minus 9, That is going to give me 44 minus 9, or 35 degrees. So this is 35 degrees, this is 35 degrees. Or the whole corner is 70. So if, and then here this is 40 and 40, and then what is left back over here, so we can make that determination, because a triangle, if I have triangle PRQ, all the angles are going to add up to 180 degrees. Well, if I know that this corner over here adds up to 70, I know that this corner over here adds up to 80, then I know the remaining corner is going to be, when you do your inverse operations, that remaining corner is going to be 30. So 30 divided by 2, that means that this angle is 15 degrees and this angle is 15 degrees. Coming up with all that kind of stuff. Now, once you have, if you see here, we have measurements on all of these angles. We have 2 measurements on every triangle created here, so we should be able to find out this, 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 and this. All of those, again, we created 3 pairs of congruent triangles, and we are able to calculate some of that information. So let's see, what are we missing out here? ARU. ARU, we said is 40 degrees. AU, goodness, we haven't done that one yet. But I know that when the incenter, one of the rules of the incenter, one of the characteristics of it is that it is equidistant from the sides of the triangle, so all of these are 20. So AT, AK, AU are all 20. So there you go, there's 20. Angle APU. Angle APU we just said was 35, and the value of X we said was 11. So we were able to fill in most of the blanks there when it came to problem number 8 and 9. Again, looking at the characteristics of the incenter, if I just jump over here to 16, 17, and 18, there I'm going to calculate something probably using the Pythagorean theorem, QT, right here. QT is going to be the Pythagorean theorem. I have a 90-degree angle, so I have A, B, C. So I would go A squared plus B squared equals C squared. And that would give me the value of that. So if I said A, B, C, it would look something along the lines of 55 squared plus 17 squared is equal to C squared. And then I could process down to find out what the heck length is QT, because QT equals C. Let's see here, what else? VST. Well, these 2 angles should be the same, so VST should be 36. And then TW, this length is congruent to this length, which is congruent to this length, because that is part of the characteristics of an incenter, is it is equidistant to the sides. So again, this would be 17 and this would be 17. So just using some of these things that we're learning and applying them across the board. These characteristics. Let's see here. So we're trying to, says this, coming up with some of this information, I can tell you that we're going to have to find a perpendicular bisector. Let's see here. So, look at some. See, Alumni Foundation was donating a new fountain to the high school's courtyard. The entrances of the courtyard are located at X, Y, Z, and they want to find the approximate location of the center of the fountain so that it is equidistant from the sides of the courtyard. So we're looking for something that is going to be equidistant from here. We're looking in this area. So we are in a position here, in using a compass, we could calculate we could do an angle bisector do an angle bisector, and then we would find out where they meet. But I'm not sure if everyone's going to have that available to them. But if I estimated, I want to cut this angle in half, so it would be something along the lines of something like that. If I cut this other angle in half, it would be something along the lines of that, and then this angle right about there. So I had to guess that would be about equidistant, or that would be where my angle bisectors in this sense, that this would equal this, this would equal this, this would equal that. That's approximate where my angle bisector would be. And I just said angle bisector, and I meant my end center. So the end center is running somewhere along the lines of 5.5 and 6 is my end center. So that's where we would want to place that to where it was equidistant. So again, just sort of making an estimate when I do my angle bisectors. And then of course, here is my potential end center. And let's see here, keeping on, I will just go ahead and leave the remainder of these for you guys to work on. But again, we're just using those thoughts. And let's see, reasoning quickly, number 22. MR is an array, is the angle bisector of NMP. Okay, so that's what they're telling us right here. They're saying, hey, this angle is equal to this angle. Find the value of X if angle 1 is this and angle 2 is that. There you go. If they're telling you those two angles are equal, then we would just turn around and make this equal to that. The measurement of angle 1 is equal to the measurement of angle 2. So there you go. Don't get too hung up on it. I think you'll all be very successful.